Calculate the angular velocity of the Earth in its orbit around the Sun. Assume that the orbit is circular and give your answer in terms of the SI unit for angular velocity. The Earth takes about 365 days to make one complete revolution around the Sun, so the period is 365 days. The angular velocity is given by 2 pi divided by period, so substituting values, we get the angular velocity as 1.99 times 10 to the power of minus 7 radian per second. In order to observe the Sun continuously, a satellite of mass 425 kg is at point X, a distance of 1.6 times 10 to the power of 9 meters from the center of the Earth as shown in the figure. Calculate using the data given the pull of the Earth on the satellite. Now F equal to gmm over r square, so substituting values, we get the force of 6.62 times 10 to the power minus 2 Newton towards the Earth. Calculate the pull of the Sun on the satellite. So similarly, we have the equation for gravitation, and substituting values, we get a force of 2.56 Newton towards the Sun. Using figure 8 as a guide, draw a sketch to show the relative positions of the Earth, the Sun and the satellite. On your sketch, draw arrows to represent the two forces acting on the satellite. Label the arrows with the magnitude of the forces. So that's the diagram, and the Sun is on the right. The Earth is this blue one on the left. Calculate the magnitude and direction of the resultant force on the satellite. So the resultant force is given by 2.56 minus 0.0662. So that will give us a resultant force of 2.49 Newton towards the Sun. Calculate the acceleration of the satellite. Acceleration is given by F equal to m, this Newton's second law. So substituting values, we get an acceleration of 5.87 times 10 to the power of minus 3 meter per second square. The satellite is in a circular orbit around the Sun. Calculate the angular velocity of the satellite. So for centripetal acceleration, A is equal to r omega square. So omega equal to square root of A over r. Substituting values, we get omega is 1.99 times 10 to the power minus 7 radian per second, and this is the same as the Earth's angular velocity around the Sun. Using your answer, describe the motion of the satellite relative to the Earth. Suggest why this orbit around the Sun is preferable to a satellite orbit around the Earth. The angular velocities of the satellite and the Earth are the same, hence the satellite, the Earth and Sun always form a straight line. From the Earth, the satellite is seen to rise and set the same way as the Sun, because the Earth is rotating around its own axis. So whenever a person on Earth sees the Sun, you'll see the satellite somewhere in the middle of the Sun. Now the advantages is that the satellite is able to observe the Sun at a fixed distance to the Sun. A satellite orbiting around the Earth will have a variable distance to the Sun. This is an advantage because if you are trying to observe the Sun, you want to keep your variables constant. It means the distance between the satellite and the Sun to be constant. The satellite will never be in the shadow of the Earth. A satellite orbiting around the Earth may be in the shadow of the Earth during parts of its motion and therefore not be able to observe the Sun during those times. Suggest two disadvantages of having a satellite in this orbit. Okay, an observatory on the Earth will not be able to communicate with the satellite at night. The satellite is very far away from the Earth and will require more fuel to put it into orbit, require more energy to transmit signals back to the Earth, experience long time lag for communication with the Earth, and be costly to repair.